In this lesson, we are going to continue to look at the volume of prisms, and specifically in this lesson, we are going to be looking at the volume of a cylinder. So here's what we're going to do. But it's all based on the same premise that the entire chapter has been based on. So the volume of a cylinder, or the volume of any prism, is equal to the area of the base times the height of the prism. Now the thing about cylinders is the area of the base is always the area of the circle. So if I was to color code this, as we're going to do, the one thing I don't do in this lesson is very much specific problem solving having to do with word problems or just extra levels of questions. We're just going to do some generally straightforward-ish ones, although you'll see there's a couple things to learn here. The area of the base is the area of this circle for this question. And for the next one, the area of the base, even though it's not on the bottom, the area of the base is this circle. So that's the first thing to notice. And the second thing to notice is that we have to multiply it by the height of the prism. So again, if I was to color code this green, the height of this prism is 11, and the height of the second cylinder is the distance between the circles, so it's actually 20. So even though it's along the bottom of the cylinder itself, that is the height of the cylinder. So the one thing we're going to have to recall here is for area of base, how do we calculate the area of a circle? Because circles are different than rectangles and triangles, and the area of this base is the area of a circle. So one thing to remember about the area of a circle, and maybe I'll make that note here, area of circle is equivalent to pi times radius squared, or in other words, 3.14 times radius again. So this squared here actually means that times by itself, not times by 2, okay? And the radius again is halfway across the circle. So that 5 centimeters is equivalent to the radius, okay? So how's that helpful? That's helpful because now we can calculate the area of the circle. If we know the radius is 5, then the area of the circle is going to be pi, which is roughly 3.14, times the radius, which is 5, times the radius, which is 5 again. And 3.14 times 5 is equivalent to 78.5. So the area of that circle is 78.5 centimeters squared. And then since we have the area of the base, we can now just times it by what I have highlighted and now boxed in green, and the volume is the area of the base times the height of the prism. So the volume is 78.5 centimeters squared times 11 centimeters, and that is going to give us a total of 863.5, and don't forget your units, centimeters cubed. Okay? And the last problem here, slightly different. You might want to try it yourself again. You might want to ask yourself what makes this different other than it being tilted on its side. The area here, remember, is 3.14 times radius. Is this 17 centimeters the radius of the circle? And if you look carefully at what's being identified, what's being identified is actually what's called the diameter, the entire way across the circle. So halfway across the circle, so that's called the diameter. So the radius is half of that. So the radius is actually 17 divided by 2, which is 8.5 centimeters. Okay, so the area of the circle is going to be 3.14, not times 17 times 17, but times 8.5 times 8.5. And that is, so be careful when you're doing these problems to ask yourself, are they identifying the radius or the diameter? Because the area of a circle is always pi times radius times radius. That's 226.865 centimeters squared. And then we're going to multiply that by the height of the prism, which we've already identified as 20 centimeters. So here the volume is equivalent to the 226.865 area of the circle times the 20 centimeter height of the prism, and that gives us a total of 4537.3, so 4,537.3 centimeters cubed. And that's the volume of that cylinder. So you may have different problems in this assignment that challenge or twist some of those thinking, but that's the basic premise of this particular section.